Everything is 2 pi except tangent and cotangent. And the viewing window is always from the phase shift plus the period. So the phase shift, comma, that's the leftmost point, the rightmost point is pi over 3, the same thing, the phase shift plus the period. Any questions on this?
I have a question.
Yes, please.
So the amplitude, you found that by the -4?
Yes, it's the absolute value always.
Okay, all right.
The amplitude is always the absolute value in front of the number in front of sine or cosine.
All right, thank you.
Thank you. Okay, page 6 here. Where am I? Yes, so for example, sine inverse of tangent x or tangent of cosine inverse x. Let's put in some numbers, so at least for one of them. So I'm going to put a 1/2 here. At least one is with x and the other one with 1/2. So we are asked to evaluate what is this and what is this. Okay, so let's start with the first one. Tangent x even for this one I need a number actually. For this one I didn't. So I'm just going to switch. So I'm going to put not a number, but a. So let me just refresh your memory on something before we go back to it. So sine is applied to an angle, and the result is a number between -1 and 1. Sine inverse is applied to a number between -1 and 1, and the answer is an angle. And this happens to all trig functions. But of course, only sine and cosine have this -1 to 1. So, sine inverse, so here we have tangent of an angle, and we will get a number. And then we can apply sine inverse to a number as long as the number is between -1 and 1. Because if this number gives us a 3, so let's say tangent x is 3, then I will have to write not possible. Because there is no angle whose sine is 3. We know that. So for this particular situation, here I don't really need a number. Let's continue. But here, sine inverse of tangent x without an angle. I can't continue here because I don't have anything about tangent x. So let's put tangent pi over 4, let's say, as an example. So in this particular case, I know that tangent pi over 4 is the nicest number of all because sine and cosine are the same number. So then I have sine inverse of 1. And I know that there is an angle whose sine is 1, and that is pi over 2. Now, on the other one is a different situation. We can use the example that I made up, or, and we should work on both, we can use the other example with a cosine inverse x. So this is the general situation, and this is just a particular example. So I know that cosine inverse of 1/2 is pi over 3. So then I have tangent pi over 3. As I mentioned, you don't have to memorize tangent pi over 3, but you have to remember that tangent pi over 3 is sine pi over 3, which is the square root of 3 over 2. And over cosine pi over 3, which is 1/2. You divide by flipping, and you get the square root of 3. How do we address this, which is a general situation? I did not put a general situation on the test, but let's look at it because it's an important example. So you know that cosine inverse x is an angle. It means that cosine alpha is x. So this is our alpha. Now cosine alpha is x, and I have x divided by 1. The other leg has to be 1 minus x squared. And we are asked to find tangent. So tangent of alpha will be x over this. So from here, look for the triangle. So it's x over the square root of 1 minus x squared. These are important examples. When we review for the final exam, we'll review this again. And on the final, you'll have an example. But I did not put one. There are simple examples with numbers on this test.
I have a question.
Any question? Yes.
So for the first one, from the sine inverse, and you found that it was 1, how did you get pi over 2?
Because on the unit circle, we know that sine is 1 is up here at pi over 2.
Okay, all right. Thank you.
Thank you. So where is my first page? Okay, moving on. So the last 3 questions are find F inverse. Exactly.
Could you share F page again?
Say it again.
Yeah, I just wanted to see the last page.
But this is the last page.
Yes, that's what I wanted to
Oh
see.
yeah, yeah.
Can I ask a question?
Yes,
about
of
the
course.
second
Any
one?
any question?
When you did the triangle and you wrote cosine of theta equals x, isn't cosine's adjacent over hypotenuse? So shouldn't the x be on the bottom?
Yes. Thank you. Stop rushing, Monica. So x over 1. X over 1. Thank you. So tangent is this over this. So I have 1 minus. Thank you so much. Cosine is the adjacent. Thank you. Thank you, Blake. Thank you. My mind was sine. So one more time, let's verify this. So cosine alpha is x, which means the adjacent over the hypotenuse. The adjacent is x, the hypotenuse is 1. So then the opposite leg is the square root of 1 minus x squared. But tangent is the opposite over the adjacent. So it's the square root of 1 minus x squared divided by x. Thank you, thank you, thank you. Thank you for paying attention. No, I did not try to see if anybody was paying attention. No, I was just careless. Good. Other questions? Okay, so the last 3 questions are find f cum g, decompose this function into inner and outer, and then find f inverse. If you feel that these are clear, we don't have to do them, and there is plenty of time for me to answer your questions. If you want to go through these, we can. You choose.
Can we go through them?
Yes. Absolutely. So I just wanted to finish and answer your questions. Okay. So we have f of x equals negative 3x plus 1 over 4x plus 3. So this is a 4-step procedure, as we know. Y equals negative 3x plus 1 over 4x plus 3. We interchange. X equals negative 3y plus 1 over 4y plus 3. We cross multiply. So 4xy plus 3x equals negative 3y minus 1. Any questions so far? Let's stop for a moment. Is this okay so far? Remember to distribute only once, meaning I distributed a negative sign only to the top, all terms at the top. So 4xy plus 3x equals negative 3y minus 1. I'm moving terms around and factoring out y. 4x plus 3 multiplied by y equals negative 3x minus 1. So then y equals negative 3x plus 1 over 4x plus 3. And this is our F inverse. I was pleased to see that on the homework, almost everyone did this correctly. Okay, so that was the 4-step procedure for F inverse. Now I saw that some of you had difficulties with this one on the homework. So for finding f cum g of x, which is f of g of x, which is f of 2x minus 1, some of my students, I will not mention any names, do this. 2x minus 1 squared equals 4x squared minus 1 or plus 1, whatever. Is this correct?
No.
This is not correct, because 2x minus 1 squared has 3 terms. Okay, so let's find f cum g. So I'm jumping over this. So f is 3 times the inner function squared plus 4 times the inner function. So we have to square this. Can anyone give us those 3 terms for squaring 2x minus 1? Can anyone give us 3 terms here so we can continue?
4x squared
Excellent.
minus 2 maybe
Yes,
4.
x, very good, plus 1. Excellent. So we have 12x squared minus 12x plus 3 plus 8x minus 4. So 12x squared minus 4x and minus 1. And the final very simple question, f of x equals 1 over 2x squared plus 9, the inner and outer. Can anyone give us the inner and the outer for this function? Inner and outer. Anyone?
Would the outer function just be 2x squared plus 9, and then the inner, the outer function being 1 over x, and then the outer function being 2x squared plus 9?
Excellent. The inner function is indeed 2x squared plus 9. Once we finish with this, we apply to this number, we apply the function 1 over x. Very good. Good. So now I'm ready for your questions. Any questions you may have? Anything? Anything that you want to work on? More examples or anything? You choose now. You pick.
Could you go over one of the homework questions we just had to do?
Which one?
It was on page 517, number 30, and it was the tangent of 2 theta equals -1.
An equation. Very good. Awesome. Awesome. Okay, so first of all, tangent 2 theta, if you remember, of course, is sine 2 theta over cosine 2 theta equals -1. In this particular case, I really, we are only asked to solve, right? We don't have to do this. Okay. So the situation that the only thing that I was going to mention here is that please remember that cosine 2 theta cannot be 0. That's all I was going to say. Now, we look at this angle, and we're basically told the tangent of this angle is -1. So there are two possibilities for tangent of an angle to be -1, because tangent is negative here and it's negative here. So 2 theta can be an angle in the third quadrant, in the second quadrant, or an angle in the fourth quadrant. And we have to find both. So, because I know that this angle has to be pi over 4, because only tangent pi over 4 could be positive or -1, then I know that the first angle is 1, 2, 3, right? The 3 pi over 4. The other angle, just extend this line, and the other angle is this. One terminal side has to be in the second quadrant, the other terminal side has to be in the fourth. And we know that this is 2 pi minus pi over 4, right? 2 pi minus pi over 4, this is 8 minus 1, which is 7 pi over 4. So, there are two possibilities. 2 theta is 3 pi over 4. Are we asked to present all solutions, or we're asked to present solutions only?
It's in the interval of 0 to 2 pi.
Right, which means that this is just a complete rotation. Good, so I don't have to add the 2 pi. I don't have to add the pi k. I would have added pi k because this is tangent. So I don't have to do that. The other possibility is that 2 theta equals 7 pi over 4. This is 2 theta, but I have to solve for theta, which means I have to divide both sides by 2. So the actual solutions, the solutions are 3 pi over 8 and 7 pi over 8. Because I obtained the solutions for 2 theta, but I have to divide both sides by 2 in order to find theta.
Okay, so like on the Pearson homework that we had to do, when you were doing a problem like this, you wrote out that, so you have like 3 pi over 4, which I understand. So you'd write 2 theta equals 3 pi over 4 plus the pi k.
If we are asked for all solutions.
Yeah, I understand. Can you let me continue? If you divide by 2 and you get the theta.
Yes, you will have pi over 2k, of course, yes.
And then you would substitute integers in for k.
You don't
Right.
have to, unless they are asking you to find particular solutions. So,
Yeah, so
So-
if you were to do that though, and like
Yes,
substitute
let's
in
do that.
a
Let's do that. Let's do that. So 3 pi over 4 plus pi k. Again, we have to verify that this is not 0. This is very important. We haven't verified that yet. So just give me one more second. So 3 pi over 2, 3 pi over 4 times 2, it's a problem. And 7 pi over 4 times 2 is a problem. So we have to be very careful. So 2 pi is 3 pi over, that's okay. They're all okay. Got it. So 2 theta equals 3 pi over 4 plus pi k. Now we have to divide both sides by 2. So theta equals 3 pi over 8 plus pi over 2k. Now, if they want you to solve, to enter whatever k, are they giving us the K?
It was, but it just said to find the answers that were in the interval that I had already said, right?
So
then
you
if
had
were to
0
enter-
to 2 pi. That's what's the interval?
yes,
Okay.
and then if you were to enter in, say like 3, 4K, you'd get 15 pi over 8, and that would fit within that interval that you just wrote down. So
So
confused
if
as to how that isn't
so
included in the solution.
let me answer this. If the interval is 0 to 2 pi, you're done. You're done. You actually, yes, you're actually correct, because if they say 0 to 2 pi, we have to find more solutions.
That is what
I
I was
agree.
confused about.
I agree. I agree. Only because these are such tiny angles, we
yeah.
have to continue. Yes. Yes. So for 2 theta, these are the options. But we have to find more angles, because these are small, tiny angles, and they are asking us 0 to 2 pi. You're correct. Okay, so let's find more angles. So these angles are obtained with k equals 0. Now I'm going to move on to k equals 1 and see what happens. Excellent. So theta equals 3 pi over 8 plus pi over 2. So theta is, the least common denominator is 8. So this is 4. So 7 pi over 8. So 7 pi over 8 is still a small angle, so we can continue. The second option with k equals 2. So I'm looking at only at this one first, and then I'll come back to the second one with the 7 pi over 4. That one may have less. We'll see. Very good point. So let me answer again from the beginning to make sure it's clear. Because the period here is pi over 2, we will have one angle in the first quadrant, a second angle in the second quadrant, and so on and so forth, because the period is pi over 2. So 2 theta equals 3 pi over 4 plus pi k. We divide both sides by 2. So this is the general solution. But if we only use k equals 0, we only find for this theta one option, but there are other options in 0 to 2 pi. So with k equals 0, we found one. With k equals 1, we found another. Let's see what happens with k equals 2. And we have to continue till we go over 2 pi, and then we have to stop. So with k equals 2, okay, so theta equals 3 pi over 8 plus pi divided to 2 times 2 divided by 2 is pi. Okay, so theta equals 11 pi over 8. So this 11 pi over 8 is in the third quadrant. So we found one in the first quadrant, we found the other in the second quadrant, and we found another in the third quadrant. So now we have to find one in the fourth quadrant. K equals 3. Theta equals 3 pi over 8 plus 3 pi over 2. The least common denominator, 8. 4. 12 plus 3, isn't it? 15 pi. So this 15 pi over 8 is 8 and 7. So this is in the fourth quadrant. This is in the third quadrant. This is in the second. And this one is in the first. So the first option has 4 different angles. Now we have to move on to the second option. I don't know how many will have the second option. Good. So theta equals 7 pi over 8 plus pi over 2k. 7 pi over 8 plus pi over 2k. Now, the first solution with k equals 0 is indeed theta equals 7 pi over 8. Let's see what happens with k equals 1. Theta equals 7 pi over 8 plus pi over 2. The least, so I have to start a new video, sorry, 1 second.